All right, welcome back. We're going to use MySQL Workbench to create our first database. Later on, we'll interact with that database with our Golang application. Now, we could create this database with the MySQL shell, but we're going to go ahead and use the Workbench. If this is your first database you've created, this is going to be a lot easier using the Workbench. And also, as your database gets much bigger with many more tables and relationships between those tables, this will allow us to quite easily make what they call as an enhanced entity relationship diagram, which is going to be a diagram of all the tables, and you're going to be able to look at that and see the relationships between the different tables much easier. So let's go ahead and get started. I have two different connections here I could click on. I'm going to go ahead and just create a new one just to show you how it works. I'm going to go ahead and give this connection a name. So when I hit OK, you can see our new connection just popped up here. We click on that, and now we're connected to our database. As you can see here, schemas is going to be used interchangeably as the word database. So these are our schemas or database, whichever way you want to call it. Even in our SQL code, let's say if we're in the shell, if we said show databases, that's going to be the same as put in the same command as show schemas. It'll return the same thing. Anyway, we have 4 different databases here, and this is one of the examples that came with the install if you chose that option. So here's my database, and I'm going to go ahead and click on the triangle here to show all the tables, and there's quite a few of them here. So if I go over to actors, and if I go to the far right and click here, it's going to go ahead and pull up the information I have in this database. So like I said, it's much like a spreadsheet. When we create the table, we define the columns, and then we can enter the data as we go on. So one row would be a record. As we get more and more people, we just keep adding more and more rows to this table. And as you can see here, there's quite a few of them. And I can just look at all these different ones, and I can close them quite easily if I want to. But anyway, to kind of get a grasp of what's going on here with all these different tables and how they're related, one thing that I can do is I can create that diagram I was talking about quite easily. If I go up to Database, I click on Reverse Engineer, and I'm going to go ahead and click Next, give it my password, click Next. This is the database that I want to go ahead and make a diagram of. Next. And I want the tables. I don't want to bother with the other stuff right now. Operation completed successfully. 16 tables from Schema. All right, here we go. As you can see here, we have our tables. This is showing us where this rectangle, where this view is. So we're in the upper left corner, and I can move around here, look at all the different tables and how they're interconnected. Here we have our film actor table, and it has a film ID. As you can see, film ID is related to inventory because it also has the film ID. So you could use that to relate to the other table and pull information that you know about one actor, in reference to, say, inventory or anything else that has, that film ID column. But anyway, I just wanted to show you that that does exist. If you want to, say, create your own diagram, maybe as you're making your database, you can just double-click on Add Diagram, and then you can just simply add your own tables as you go. I'm not going to go too in the depth on everything here. This is just kind of an overview, so you can kind of know what there is in MySQL Workbench, as well as we're basically going to create our database, which we're going to interact with later. Okay, so I'm going to go ahead and click back here, back on test 2, and let's Close that. And we want to go ahead and create our own database or schema. So over in the space over here, I'm going to go ahead and right click and then click Create Schema. And I'm going to go ahead and give it a name. And we're going to say test DB. And go ahead and use the same name so it'll be the same as our example we'll use later on. We'll hit apply. And it's actually going to show us the SQL that's going to run to create this database. You could actually copy this and you could paste it into the MySQL shell and you could run the code that way. You just wouldn't want to try and create the same database twice because that wouldn't work. I can hit apply, and as you'll see, we should pop up a test DB over here. There we go, test DB. And if I go over to test DB, tables, views, stored procedures, functions, I'm going to go ahead and right click on tables, and I'm going to choose create table. And we're going to go with students as our table name. And we're going to go ahead and create some columns. So our first column, we're just going to call it ID, and int would be great. And the next one's just going to be first name and last name. Now, so we have 3 columns in our table. We haven't created yet because we haven't hit apply. Just as a heads up, PQ is for primary key. So the primary key is going to be a unique identifier. There's only going to be one of those. So if I know that's a primary key, it's going to be unique and it cannot be empty. So it's kind of like a social security number. Everybody's supposed to have one. And it would be if someone didn't have one, that would be an issue. So a primary key is going to be not null. So it means it has to have a value. So if no value was entered into a field, well, that would be a null value. And this one will not accept a null value. So if we try to enter something where there was no value trying to be entered into that, say if we had a first name and a last name but no ID, it would error. It would not work. A unique index just means you can't have multiple of it. Like I said, with the social security number, if you search that up, you should find one person. Sorry for using the American examples, but there should only be one person in that set. So if you're searching for it and you find that number, you have your only entry and you can retrieve it. You don't have to go through all of them to see if there's duplicates. You know that there's only one. Binary column means you're going to have an array of bytes. Unlike something like varchar 45, that's going to be an array of string characters. But yeah, this one would be bytes, so it's going to be binary. Unsigned data just means it's not going to accept any negative values. It's going to be 0 or greater. And zero fill, let's say you want it precise to 3 decimal places. Let's say you enter the number 5 in there, it would save it as 5.000. So you're basically, it's going to fill in the zeros for you. Auto increment, this one's actually pretty good with the primary key. So say if you didn't provide a primary key number, I'll go ahead and auto increment. Just a great way to have it count up and you don't have to worry about it. A generated column. This one is going to use an expression to return a value and place it into that column. Let's say you have a length and a width as 2 of the different columns. Well, this one could actually take those 2 values, multiply them, and this one could provide you the area, let's say, of a rectangle, for instance. So anyway, I don't want to get too far off in the woods there. Here are the data types for each one of these. Like the first one here for the ID, that is an int. We've gone over those already. Varchar variable character, so that's a string of characters. Decimal, so it doesn't have to be a whole number. We have our date time. We also have a blob, which is a binary large object. You can hold a variable amount of data. But anyway, as you can see, we have several different kinds of data types here, from floats to ints, whatever you're looking for there. You can be real specific with those if you wanted to try and save some memory when you're just playing around with a database like this. If I wanted make this varchar a little bit bigger than just 45 characters, I might say put 200 or something in there. Playing around with a sample database, you don't have to be as cautious as when you start to scale up. You might want to be a little more careful. Anyway, so we have our table name. We've created 3 fields. We've set the data types. We've set this one as the primary key. Remember, we have to have a primary key set so we can enter values later. And let's just hit apply. And as you can see, it creates the SQL for us. Like I said, you could drop this into the MySQL shell. You could run that and create your own table. So I guess you could use this as a little way to cheat if you forgot how to do something. You could alter the tables in here, and before it applies it, it shows you what the MySQL, SQL script is. As you can see, these capital blue ones here, these are the keywords within the language. Those aren't the words that I provided. Like I provided the name of the database, I provided the name of the table, the ID field, first name field, last name field, and these are just keywords within the language. So, and it's kind of nice to have those kind of color coded to make it a little simpler to follow. So I'm going to hit apply, create our table, finish. And if I go over here and click on the triangle, I have my students table. I'm going to go ahead and click here. I can show I don't have any values yet. So let's go ahead and add a value. And I'm going to go ahead and hit apply. Well, let me explain what we're looking at here. So up here, you can see this is a select statement. If I run this, it's going to show me what I have in this table so far. It's going to select all. That's our wild character. So it's going to grab everything from the test DB database students table. So if I click this here, it's going to execute that query. Oh, actually, okay, and it just shows it down here. And then anyway, ID 1, Jane, first name, Doe. Okay, let's go ahead and hit apply here. Okay, as you can see, it's going to go ahead and insert into the TestDB students table. And what we want to insert is the ID field, first name field, last name field, and the values of 1, Jane, and Doe. There we go. And if we wanted to add another, we can simply do that. Now, let's say if I want to change this, I can just go in there. And it's still not, like I said, not applied until you hit apply. So if I hit the select, it's going to go ahead and return all the values. You can see, since I didn't hit apply yet, it was still Johnson. Let's go and change it to Smith. And we're going to update. Don't worry too much about the syntax. We'll go ahead and cover that further later. Kind of just going over MySQL Workbench for right now. Anyway, it's going to update the TestDB database students table, and it's going to set the last name column to Smith, where ID is equal to 2. So I'll hit apply. And it's, notice how they're making their query. They're say where the ID is. You could use a statement that says where last name is equal to Johnson, change it to Smith. But you would want to be careful with that because you could have several different Johnsons in there and it would go ahead and switch all of them to the last name Smith. like I said, the ID is our primary key, so it is a unique identifier. So once we find that, we know that we're only changing this one record. We don't want to change all of them in this particular case. So if you want to just change one, make sure you're using that unique identifier, that primary key. And if I wanted to delete one of these, remember where it's at. Oh wait, I'm sorry, delete row. There we go. Now if I hit apply, delete SDB database, the students table where the ID is equal to 2. All right, there we go. Like I said, I wasn't intending to go over everything here, but I hope we went through quite a bit of it. If you wanted to drop the table or delete the table or the database, let me show you that real quick. You actually click on your table over there. You can go over and you can drop the table, and it can show you the SQL for that. You would want to be very careful with anything that says drop, because you may not be able to get that stuff back, especially if it's a database. There could be several tables in there, and there's not a lot of fail safes in there to stop you from deleting your own stuff. So I mean, it's real easy to accidentally take a whole bunch of stuff out. Well, and probably in our next video, we'll look at the MySQL shell. We'll probably look a little more at the syntax. But anyway, if you're new to using creating databases, like I said, this is very handy where you can alter the data and it can show the SQL statements. It's a nice little way cheat that way. But if you really, over time though, the really complex queries that you're going to want to use, you're probably going to be using those in the shell. You're going to be writing those in your Golang code as well to execute. But anyway, I hope that was helpful. If you have any questions, please put them down in the comments below. And I'll see you in the next one.